Welcome to the Machine Learning at Home. Today I will try to explain how to plot the machine learning. So far I explained how to plot the misclassification tables with association plot as SOC plot. You can plot either table or even like results of misclass function, doesn't really matter. But how to plot the prediction process? So that is a question. This is related with the nature of the data you typically use for machine learning. This is multivariate data, so it contains multiple variables. Multiple means more than two. So if you simply plot any multivariate data, you might see some strange results. For example, let us go take the bold approach and without much thinking just plot the iris data. So what you see here is so-called paired plot. So paired plots are very good, but they're not actually useful in our purposes. They're too complicated and not easy to see what you want. It simply plot each variable against each variable in that case. But we need the kind of bird-eye view of the data. How to make it? Well, here principal component analysis or any other dimension reduction technique will help. That technique will convert our data from being multidimensional into small dimensional, like 2 or 3 dimensions. So let me show how to make a principal component analysis. First of all, we should run a function printcomp and then apply it to some data, of course without a species variable. Printcomp only wants numerical measurement type of data, so iris -5. And then of course we need to save this result in some object, iris p, for example. And from that iris p we need to extract the new coordinates, so I call it iris pp, and then coordinates lay in iris.p, $sign for components, component name is scores. We only need two first principal components, so 1, 2, 2, and this is it. And now if we plot iris.pp, there will be much better view, so you can see some dots in two-dimensional space, and even more clear it will be if we plot and colorize dots by species, like say col for color is as numeric for conversion into numbers, iris variable number 5. So this is how to colorize our dots. And now if you look on a plot, you will see that principal component analysis separated species quite well. You see the black one, which is setosa, because it's alphabetically first. Then there is a versicolor for red, because it's VE, and virginica with green color, because it's VI. Okay. And now we're ready. We're now ready to go some machine learning, but we should learn on that reduced data on iris pp. So this is not very much useful, but for visualization and for understanding how machine learning works, this representation would be quite useful. So let us learn it. You will need my library first. Library Shipunov, for example, and any of machine learning libraries you already know. Let us go, for example, with a neural network. So library and net. And then we make a neural network out of iris.pp data, not from initial data, but from pp data, because it's what we want to plot. So iris pp and net, And for simplicity, I don't want to have a training and testing subset. You can make them if you like, but I will use a whole data as a training. So I will use the whole data as a training, as we did in some examples before. It shouldn't be very new to you, that approach. And net species against all other variables. In that case, these are only two numerical variables, but look, we don't have a species in iris pp because when we created it, we took out of variable number 5. So we should return it back again with cbind column binding approach. We should bind iris column number 5 to the actual iris pp. The resulted data set, this one, will be 3 columns. One column is for species, and second and third columns are for new variables which we extracted from scores at some point. So hope it's not very complicated for you. So why I did not put a comma here? Because I want to retain the column name, which is species. That's why. Okay, and for neural network, we must also provide a size of intermediate layer. Size, for example, equal to 4. Okay, so it reached some good error value, lower enough to stop and converge. Now we go and we provide that plot thing, the function to plot a result of machine learning called GRADD, GRADD. This is a plotting function. It will only plot to the existing plot. So it's called low-level plotting. So we must have some plot, and then we plot something in addition to it. That function will use the name of the model, iris, pp, and net. It will also use the initial data, iris, pp. And also we need to tell what exactly we need to work with. So we need to tell GRAD which type of model we have. For neural networks, type of model is 3. And then I want you to see borders between group which that machine learning provided. So we need to plot, so argument what? Lines. Okay, so again, GRAD function will use a model name, initial data, type of model, because it can accept multiple different types of models. I will give you more examples. And also you can supply it with what exactly to plot. This is not default option. I just want to see how it works. Okay. And look now on the plot. 2 gray lines appeared. These lines are results of machine learning. So machine learning from neural network provided us with these 2 lines. These lines supposedly separate setosa from versicolor from virginica. Of course, there are some mistakes. Look on these 3 red dots which went into the wrong group. These are mistakenly classifying samples. So this is a visual illustration of misclassification as well. Oh, by the way, there is a 1 green dot which went into the red group as well. So this 1, 2, 3, 4 are not exactly well classified. Everything else is good enough. So that's how to work with GRAD and how to illustrate machine learning. Let me give you one more example. I will plot my pp data back again, and then we'll use another GRAD with default option without what lines. In that case, it will fill the whole rectangle with multicolored dots, 3 colors. One for Setosa, one for versicolor, and one for virginica. So it, by the way, represents what exactly GRAD is doing. GRAD will take every single location on that plot and then will apply it to the model. And model will predict what species is it. For example, GRAD will take some position of -2, -1, this position. Then apply it to the our IRIS-PPNet model. IRIS-PPNet model will predict that species is versicolor. So GRAD will colorize this dot in red. So this is actual visual representation of the machine learning process. A bit artificial, unfortunately, but quite useful for understanding how a model is working. You can see, for example, that neural network model is non-linear and makes kind of strangely curved lines. And then let us demonstrate another variant of machine learning plotting on something else. For example, library random forest. Random forest. And we call it, of course, for making some random forest model. So I will make a random forest model in a way similar to what we did with neural networks. IRIS-PPRF, I will call it. I will not change the cbind. I only remove size because random forest doesn't need any sizes. And name of function will be, of course, different. It will be like a name of model. Random forest. Okay, everything else looks like it's good. Okay, we did it. And now we plot again our PP dimensionally reduced data. And then plot GRAD something else to it. For example, I want to plot lines again. And for the model, I will use our new RF model. Type of model in that case is IDS. To know which types are available, you should read help for the GRAD function. It explains everything and contains plenty of examples. So type IDS and what are lines. Okay. Now look, so random forest is funny. It starts with kind of vertical lines, but then it's tried to change them just a bit to allow some unusually placed samples to fit better into the groups. So some of samples went into the wrong group, like this one, but most of them classified pretty well. So this is how random forest is working on the IRIS data, modified variant of IRIS data, which has only 2 principal components left. Alright, so this is how to plot machine learning with a GRAD function, and it has 2 options, either lines or default one with dots, and can allow multiple types of machine learning models or even some user-made models if you are more or less advanced and can provide it. Thank you very much.